Okay, so what we are talking about today is going to be binomial nomenclature of ionic compounds. So binomial nomenclature of ionic compounds. So binomial is going to mean two names. So to name an ionic compound, we're going to use two names. The first name is going to be the cation. That is usually going to be a metal. The second name is going to be the anion. That's usually a nonmetal. And we're going to replace the ending of the second name with "ide." And this isn't going to work for every single type of metal, and we have another video out for how to do it with the transition metals. But this is going to work for every metal that we know the charge of based on its position on the periodic table. So what I mean by that is we've got this whole first column where we know everything's going to take on a +1 charge. This will work. We've got this whole second column where it's going to be +2. And then way over here we also have this third column, which is going to be +3, at least down to gallium. Okay? Now the nonmetals are always going to behave much better for us. They're always going to have this -3, -2, and -1 charge. Now there are a couple exceptions in here that I want you to know about. Silver is always going to be +1. Zinc is always going to be +2. So they will also work for this. Okay. So first one I want us to do is going to be Mg, magnesium, Cl2. Now, when we follow our naming rule, the first thing we're going to say is the cation. That's the metal. That would be magnesium. So I'll say magnesium. And then we're going to say the anion, which is chlorine, but we're going to replace the ending with "ide." So instead of saying magnesium chlorine, we're going to call it magnesium chloride. Okay, so again, we replace the ending with "ide." So another example is K2O. This is going to be K, so I say potassium. Okay, and then I will also say the O, which is oxygen, but again, I'm going to replace the ending with "ide." So it'll be oxide. Notice on these metals I don't use a Roman numeral and I don't use any prefixes whatsoever. I literally just say what is the first thing and then what is the second thing and have it end with "ide." Alright, now what I think is a little trickier is going the other way. So if I were to look at the same compound and say, okay, it's called magnesium chloride, how do I know that it needs to be 1 magnesium and 2 chlorines? Well, here's how. If I know that it's made out of magnesium and chlorine, let's draw a picture of 1 magnesium. And we need to know what is magnesium's charge. Well, conveniently, magnesium is one that we always know the charge of. When in an ionic compound, it will take on a 2+ charge. Okay, so I'll draw 2+. I also know I have chlorine. And chlorine's a nonmetal, so I know what charge it will take on. It's going to take on a -1 charge. -1 charge. So ionic compounds are neutral, even though they're made of charged particles, meaning this whole thing needs to add up to 0. Well, right now, if I have 1 magnesium, I'm +2, and 1 chlorine, I'm -1. That adds up to still have a positive charge. I'm more positive than I am negative. Well, to remedy this, we're going to add another negative thing, Cl-. Well, now I'm 2+ and I'm 2-, meaning I have a total charge of 0, so that would be 1 magnesium and 2 chlorine. So I'm able to recreate what I had based on the name. Okay, so for these ones, all you need to do is say the cation and the anion ending with "ide," and that will give you enough information to also be able to write the formula. So let's do one more example of this with one that we don't already know the answer to. I could say boron sulfide. So boron is going to be boron. So right, I didn't change the name at all. So find boron, and this guy is going to take on a 3+ charge. Remember, don't just take an element that starts with B, right? So this is not beryllium, this is not barium. Just be careful that, don't pick an element that's close, pick one that really is the one that we're using, so boron. And then sulfide is just sulfur with, the ending replaced, so I find sulfur. And it takes a 2- charge, so I'll draw that. Right now I am more positive than I am negative, so I need another negative. Now I'm -4, but I'm +3, meaning I need another positive. Now I'm +6, but I'm -4. I need another negative. And now I'm entirely neutral. So I know this is going to be 2 borons and 3 sulfurs. Okay, so that's how you are going to name an ionic compound that has, what I'd call the normal metals, the metals that we know the charge of. There's another video on how you do those tricky ones in the middle called the transition metals. All right, email me if you have any questions.